Welcome in Dark Core. When it comes to the strange world of physics, you'll find many different substances and materials that don't quite act like you think they should. Some elements are naturally occurring, but some are man-made. From Terminator liquid metal to the strongest known material in the universe, check out these things that defy the laws of physics. The name ferrofluid is actually a combination of the words fluids and ferromagnets. These ferromagnets are very strong and display permanent magnetism. Mix this with a fluid and voila, you have a magnetic fluid that can be manipulated. Ferrofluid is usually a mixture of finely ground ferromagnets that are coated with a surfactant to prevent the tiny magnetic particles from sticking together. They are then mixed with an organic solvent or water. The cool thing is that these ferrofluids take on a lustrous spiky shape that can be morphed into different sizes or patterns in the presence of magnets. When the solution is exposed to a magnetic field, the ferromagnetic powder experiences force along the magnetic field lines. But it's not just a magnetic field at play here. In fact, the surface tension of the surfactant is the other force. And you might not know this, but the outermost layer of all liquids has slightly higher energy than the remaining molecules of the liquid. So that neat ferrofluid spiking you see is caused by magnetic force, gravity, and surface tension. But there's more than just fluid that behaves strangely. Sulfur hexafluoride, or SF6 gas, as it is usually called, is a heavy, inert, non-toxic, and incombustible gas. It's mainly used as an insulation medium in electrical transmittance systems, electrical distributing devices, and displacing gas mixtures in metal smelting. It is colorless, innocuous, and non-flammable, and it's very dense, weighing 5 times as much as air. Other than being used in industry, this inert gas can do some crazy things like lower the tone of anyone's voice when inhaled, like helium. Since it's so heavy, you can actually fill a container with the gas and float things on top of it as if it were water. It can also be poured like water over lit candles and extinguish them. While all this sounds cool, it might be worth mentioning that SF6 gas is 23,500 times more warming than CO2, making it one of the most powerful greenhouse gases. The next material is called rubidium, which is a very soft, silvery white metal and is the 25th most abundant element found on Earth. According to the periodic table, it is also one of the most highly reactive elements and has a density of about 1.5 times that of water. It is solid at room temperature but has a low melting point of 102.7 degrees Fahrenheit and will turn into a molten metal if it reaches this temperature. We mentioned that it is highly reactive, and like other alkali metals such as lithium, potassium, sodium, and cesium, it reacts violently with water. This is because of its super high oxidizing properties. It reacts with oxygen and can ignite simply from humidity in the air, which releases hydrogen and immediately bursts into flames. A fun fact, rubidium salts are used in glasses, ceramics, and it can be used to create purple-color fireworks. One of the other interesting things about rubidium is that it can easily be ionized and possibly be used as a propellant for ion engines for future spacecraft. No, that was not the Terminator metal we were talking about. This liquid metal really does seem to defy the law of physics. We're talking about gallium, which is a soft, silvery blue metal when it's at standard temperature. But put a piece of gallium in your hands, and it will turn into liquid metal, melting right in your palm. It's primarily used in electronics and microwave circuits, high-speed switching circuits, and infrared circuits. Gallium nitride and indium gallium nitride are used in light-emitting diodes and diode lasers which produce blue and other colors. It has been called a Terminator metal by some, as it acts as though it's alive. When mixed with hydrogen peroxide, it can also melt through aluminum. Of all the metals, gallium has one of the largest ranges of when it's in liquid form. The reason that it doesn't react with air and water is because of its layer of oxide. You might hear more about gallium in the near future because of its antibiotic properties, which cause bacteria to die, and researchers are also studying the oral intake of gallium to treat cancer. Next, we step into the bizarre world of textiles and wearable technologies. Smart textiles and fabrics developed with new technology that provides some added value to the wearer. Apparently, these smart fabrics have the ability to communicate, transform, conduct energy, and even grow larger. Some fabrics gather energy from the environment by harnessing heat, sound, or vibration, and then react to those elements. New fabrics are being developed for protective clothing to guard against radiation and the effects of space travel. Some fashion designers have made clothes that not only light up, but the materials react to body temperature and move on their own. Other designers have made clothing that lights up and changes colors and patterns using the smartphone. A fashion designer by the name of Yingao created 2 dresses made of photoluminescent thread and eye-tracking technology and is activated by the viewer's gaze. The 2 dresses in question appear to be alive and moving on their own. And speaking of bizarre materials, just recently scientists discovered a new type of self-healing material, or what is called self-healing polymers. Researchers used a catalyst based on a rare metal called scandium and created polymers composed of alternating sequences of ethylene and N-hexylpropylene in shorter ethylene-to-ethylene segments by the copolymerization of ethylene and initial propylenes. In short, these polymers are somewhat alive. The elastomer copolymers are very tough and can be stretched to the point where other elastomers would break. But the remarkable thing is that they showed self-healing abilities when cut into 2 pieces and then put back together. When the 2 cut pieces are put back together, the microscopic materials autonomously self-heal. Think this has something to do with just being sticky? Well, this self-healing polymer can not only repair itself in dry conditions, but also in water without any external energy or stimulus. Imagine the future having many things made of this material that, when broken, can heal themselves. When it comes to things being able to spring back into their original shape, the alloy nitinol should be mentioned. Also known as nickel titanium, named after combining the 2 elements, shape memory is one of its unique properties. Nitinol can be deformed or bent at one temperature, and then will transform back into its original shape when it reaches a temperature slightly higher than when it was deformed. Wonder how that works. The unusual properties of nickel titanium are derived from a reversible solid-state phase transformation, which is known as martensitic transformation. At high temperatures, nitinol assumes an interpenetrating simple cubic structure called a parent phase, referred to as austenite. At low temperatures, nitinol spontaneously transforms into a more complicated monoclinic crystal structure called a daughter phase, or martensite. Our next material certainly has a bizarre beginning. It is called starlight and is surrounded by mystery. The material is able to withstand and insulate objects from extreme heat. It was invented by a British amateur chemist and hairdresser, Maurice Ward, back in the 70s and 80s. Often called the wonder material or blast-proof material, this unknown substance remains a mystery. In fact, the composition of the material was only revealed to Ward's closest relatives. One of the most impressive tests done on the material was using a high-powered laser under military laboratory conditions, simulating a nuclear flash. The laser heated the material to an astounding 18,032 degrees. After the starlight material cooled down enough to handle it with bare hands, a knife was used to crack it open, and the egg was still 100% raw. This next material is definitely an attention grabber. It's called aerogel, and it's sometimes called blue air or frozen smoke. The interesting thing about this one is that it was also an invention and the result of a wager. It all started back in 1931 when a guy by the name of Samuel Stevens Kistler bet someone named Charles that he could replace the liquid in jelly with gas without causing the jelly to shrink. Well, he won that bet and produced aerogel by very slowly removing the liquid, which left behind just a solid structure. But some surprising things were discovered after making the super lightweight material. All that trapped air inside the gel makes it an incredible insulator. For instance, silicon aerogel has a thermal conductivity of 0.03 watts per meter Kelvin in atmospheric pressure and 0.004 watts per meter Kelvin in a modest vacuum. That's very similar to air itself. If the material is held to a flame, you won't see much happen. In fact, silica aerogel won't melt until 2,000 degrees Fahrenheit. Anything can be completely insulated from heat using this material, including flowers, crayons, and you can't even get a patch to ignite with a torch on the other side applying heat. While we're on protective materials, we should probably not forget to mention graphene, which is an allotrope of carbon, meaning it can exist in 2 or more forms. In the form of a single layer of atoms in a 2-dimensional hexagonal lattice, in which one atom forms each vertex. Aside from all the confusing things, in proportion to its thickness, it is about 100 times stronger than the strongest steel. In fact, it is one of the strongest materials in the known universe, yet its density is dramatically lower than steel, and it conducts heat and electricity very efficiently. But unlike steel, it's nearly transparent. Graphene has so many pros versus cons that it has a wide range of uses, such as being used in flexible electronics, composites and coatings, sensors, and much more. We hope you enjoyed the video. Which one of these was your favorite? Tell us in the comments. And if you liked the video, then give a subscribe button a click and turn on notifications so you'll be the first to know when a new video arrives. Thanks for watching. Cool.